Hello everyone. In this video, I want to teach you some basic about the Vivado HLS. Vivado HLS is a high-level synthesis tool that converts C, C++, and System C code into optimized RTL suitable for FPGA implementation. It enables faster design exploration by allowing developers to apply directive, constraint, and to efficiently generate hardware from algorithmic descriptions. The figure illustrated in this slide is the typical workflow of high-level synthesis, beginning from C-based design and verification and progressing toward RTL implementation. First, the C code and its test bench are developed and validated through functional verification. The verified C model is then synthesized into RTL using the HLS tool, where various directives and constraints may be applied to optimize the performance, area, or latency. After synthesis, CRTL co-simulation and implementation evaluation are performed to ensure that the generated RTL behaves correctly and meets the design requirement. If the design doesn't pass verification, additional constraints or modification are applied and the process is repeated. The process should be repeated here. Once all evaluations are successfully passed, the final RTL code is exported for downstream hardware implementation. This step, I mean. Okay. In the next step of this tutorial, I will show you how we could start an example in Vivado HLS and then do the steps to generate an IP and export it Vivado tool and then use it in that tool in order to complete a project. Okay, well, in the next step, to show you the example, open the Vivado HLS and then create new project. Choose a name and a destination for the project and next. Here you have to add or remove C code files and the top function. For the top function, I will choose adder and later I will write the code for the C main source file. Okay, and here I have to add C-based test benches. Again, I will do it later. The solution name should be defined here because I start the project right now. There is no need for changing the name of that. The clock period is 10 nanosecond here in this example, and I could also define an uncertainty, otherwise I could leave it as default. And then for the part, again, I could go to this. And from the boards, I will choose Z board. Okay, and then finish. Here I'm gonna add the source file by right-clicking on this source folder and add file if the file is already available, but if you want to write it down, you should choose new file and then choose a name for that. Adder.cpp. The code is very simple. We have to complete it like this. It is a function with the name of adder underline HW. This function takes two integer inputs, A and B, adds them together and store the result in a temporary variable with the name of temp. And then it returns the sum as the output of the function. In the next step, I have to create a test bench for this example and then give a name to that. main.cpp and save it. And then complete the code like this. In this code, this program will compare the result of hardware adder function, the function adder HW, with the software, with this software addition. And then if these two values are differ from each other, then it will print error. Otherwise, it returns 0. Okay, I will save this test bench file, and then I will go to project setting. In the synthesis tab, I will browse to add the actual top function. Then I will run, as you could see, this option, which is C simulation. There is no need for launching debugger because the code is so simple. Okay, as you could see, the simulation has been completed without any error. You should check the console tab. System done with 0 errors. We will go to the next step, which is run C synthesis. The next step is to run CRTL code simulation. CRTL code simulation is a verification method that runs a C or C++ reference model alongside the synthesized RTL design to compare their outputs cycle by cycle or test by test. It actually ensures the hardware generated from high-level code behave exactly the same as the original software model. Okay, so I will run CRTL code simulation. I have to select the RTL Verilog or VHDL. By checking the console, it seems that the CRTL code simulation has been finished. So I could go to the next step, which is exporting the IP. And it's okay, the IP will be generated from this adder C code that we written in this example. Again, if you check the console, you could see that the exporting RTL or generating the IP has been finished here. After IP creation in Vivado HLS tool has been completed, I will go to the Vivado tool in order to create a project and use that IP in the new project. I will give a name to this new project, test adder IP. Then next. Again, don't specify sources at this time. Next. Here I will choose Zibo board because it has been always our target board in these examples. And then finish. Okay, then I will create a new block design. In order to be able to use the generated HLS IP, we have to go to the setting and then in IP repository, then add the path of the generated IP here. This is the adder HW IP, and by clicking on OK and apply, it will be recognized later in this project. Then I will continue to complete the project in order to test the generated IP. So I will choose that IP and then adder The other WIP is now added to the project, and then I have to add another IPs in order to provide the value to A and B and the AP control. For that, I will add 3 constant IP. And connect each of them to A and B and a start of the AP control bus. Then by double clicking on them, I will change the constant width of the B to 32 and the value to 5. Constant width of the A again to 32 and the value to 4. I want to make them the same as what I did test in the Vivado HLS simulation result. Okay. And then this one, the last one, constant width to 1 and then constant value again to 1. Then I will choose regenerate layout in order to make it tidy. Right click on this one and make it external. And also I will do the same for these 3. Make external. Okay, the block design is now complete. And then I have to go to source tab again. Right click on this block design and generate output products. Then generate. Again, after generating become completed, I will right click on that, create HDL wrapper. Then I will go to run simulation and run behavioral simulation. The simulation result waveform will be opened after that, and by zoom fit, you could see the result. As you could see, the AP return value is now 9. It's clear, it's very simple. 4 plus 5 is 9. So if I want to summarize what I have done, I start a project in Vivado HLS and write down 2 C code, one for the adder IP, another for simulation test bench. And then after doing the simulation and synthesis in Vivado HLS and exporting the hardware, I import the IP here and add it as an IP in an example, and then do run simulation and see the result of the generated IP in the Vivado environment. Okay, this video has been finished here. I hope the content become useful for you.